Hello. In this video, I'm doing an application to complex numbers. So complex numbers are applicable in many fields of science and engineering, but most of the applications are beyond the scope of what we cover in college algebra. I'm just going to show you one example to electric current or alternating current. I'm not going to worry too much about what the Ohm's law means or anything like that. We're just going to do the operation. So complex numbers are used to describe the current I, voltage E, and impedance Z, which is the opposition of the current. These three quantities are related by the equation E equals I times Z. Thus, if any of these two quantities are known, the third can be found. In each exercise, or in the exercise below, number 88, solve the equation E equals IZ for the remaining value. Okay, so we have E equals IZ. So I times Z equals C, where E is 57 plus 67I, and Z is 9 plus 5I. So I times 9 plus 5I equals 57 plus 67I. We need to solve for I, for big I, and I is 57 plus 67I over 9 plus 5I. So we are going to use the conjugate of the denominator to solve or to simplify this quotient. When we simplify this quotient, we want to have one real part and one imaginary part. That is one constant and one number multiplying I. And multiplication of complex numbers or quotient of complex numbers. If we want to write it in standard form, A plus BI, we multiply by the conjugate of the denominator. So the denominator is a real number. So that is going to be what? The denominator is going to be 9 plus 5i times 9 minus 5i. That's going to be 9 squared. And then minus 45i plus 45i minus 25i squared. And the numerator, we're going to FOIL. 57 times 9, it's 513. 57 times minus 5i, it's 285i. 67i times 9 is 603i. And 67i times minus 5i is going to be minus 335i squared. So next we're going to simplify. We add or subtract complex numbers the way we do polynomials by combining like terms. So combine the terms with I and the terms that don't have I. And I squared is -1. Okay, so this 513 and then minus 285i plus 603i, it's 318i. And then plus 335. Then 9 squared is 81. This to cancel. And -25 times -1 is positive 25. Okay, we're almost getting there. 513 plus 335 is 848. And 81 plus 25 is 106. So now we can separate the real part and the imaginary part. The real part is 848 over 106. And the imaginary part is 318, 389 over 106. 848 over 168, and that's the value of big I. And 318 over 106 is 3. And that's it. So the value of what the I was the current. So the current is 8 plus 3I. Thank you for listening.